Let's talk about writing a ratio table. Okay, so a ratio table can show us different multiples of numbers. Let's say I wanted to make a ratio table of the multiples of 3. I can say 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. I'm just going to go up to 7. Okay, so here is a ratio table. Each of these could be considered equivalent ratios, 1 to 3, 2 to 6, 3 to 9, 4 to 12. These numbers, you can see, are going up by 1 every time I'm adding 1. Down here, my value is increasing each time by 3. Just like in our double number line we did the other day, we're just adding the same quantity that we started with. But one other thing you can notice, as these each increase by 1 and these each increase by 3, there's also a relationship between the two rows. There's a relationship between the two rows. Because look, if I did 1 times 3, I would get 3. If I did 2 times 3, I would get 6. If I did 3 times 3, I would get 9. If I did 4 times 3, I would get 12. So there's also a relationship to get from one row to the other, and that is we're multiplying by 3 to get from this number to this number, we're multiplying by 3. So not only do we have a relationship moving across our ratio table, we also have a relationship between the two rows. Okay, so let's take a look at finding some missing values in our ratio tables. So here I have a ratio table that's half filled out, and I have a ratio of teachers to students, and I have one teacher for every 16 students. So I have one teacher for every 16 students. Well, how many would two teachers have? How many students would two teachers have? So again, we moved from here to here, we added 1. So down here, we're going to add that same quantity. We're going to add 16. So 16 plus 16 is 32. If I add 16 again, 32 plus another 16, I'm going to get 48. Up here, I was adding by 1. So if I add 1 more over here, I'm going to have 3. Okay, I also could notice I could have figured out 1 times 16 is 16, 2 times 16 is 32, and 3 times 16 is 48. So I could have used multiplication as well as addition. Let's take a look at this next one. Okay, here I have groups and of people. So one group has a certain amount of people. 2 groups have 6 people, and 3 groups has a certain amount of people. And if we're using the same ratio of groups to people, then our numbers are going to grow at the same rate. So again, we see here we have 1, 2, 3. We're adding by the same quantity each time. Here I added 1. Here I added up 1. So how did I get to 6? Okay, how did I get to 6? What number should go here? What number should go here? Well, this is where I might need to use that relationship between the two rows to help me. I know that 2 groups that make 6, that means that I'm going to have 3 in each group, because 2 times 3 is going to get me to 6. 2 times 3 gets me to 6. So 1 times 3 is 3. 3 times 3 is 9. And look, I can see this, I could also go plus 3, and that gets me 3, 6, 9. So I'm going to use those relationships between my numbers to figure out what the missing numbers are. Let's try another example. Here I have trumpets to drums. Trumpets to drums. Now this one's a little bit different than what we saw in the other ones, because in these ratios, as we just went 1, 2, 3 at the top, 1, 2, 3 at the top. Well, this is a little different. I have a 10, then I have a 5, I have something missing, I have a 25. So these aren't going in any particular order. So I really need to think about the relationships between the numbers that are in my ratio table. For every 10 trumpets, I have 8 drums. I had 5 trumpets, how many drums would that be? So I need to think about, well, there's nothing here. And I really can't think of a very good relationship between 10 and 8. But I do know that there's a relationship between 10 and 5. I know that 5 is half of 10. 5 times 2 equals 10. 10 divided by 2 equals 5. So, you know what? If I'm going to divide this by 2 to find half, let's find half of 8. I know half of 8 is 4. Half of 8 is 4. Okay? So that I divided by 2 to get from 10 divided by 2, 8 divided by 2. So I can do the same multiplication or the same division to get from one column to the next. So here I am missing this number up here. Well, let's think about, it's going to be something with a 16. There's nothing I can think of that multiplies 5 times something to equal 4. So let's just go this way. How can I get from 4 to 16? How are they related? Well, I know 4 times 4 is 16. 4 times 4 is 16. So that was times 4. So I'm going to do times 4 up here as well. Times 4. 5 times 4 is 20. 5 times 4 is 20. All right, so that is one way that I can figure out my ratio 20 to 16. So 10 trumpets to 8 drums is equal to 5 trumpets to 4 drums, which is equal to 20 trumpets to 16 drums. Now my next number is a 25. I don't really know any relationships between 20 and 25, but I do know how to get from 5 to 25. I know how to get from 5 to 25. 5 times 5 is 25. So actually I'm going to do from 5 to 25 times 5, and down here 4 times 5. 4 times 5 gives me 20. So I can fill in that ratio because I'm multiplying by the same amount. Okay, so there is a lot of different things you need to think about, and the way that the numbers go together, the way the numbers work together and are related to each other to figure out some of these ratio tables. All right, so you're going to work on a few of these today, and we'll be doing some more as the week goes on.